All right, welcome back everybody to the Additive Snack Podcast. I'm your host, Fabian Feld, and today I am joined by somebody who sits very closely to the pulse of additive manufacturing. And he's also not a newbie to this show. He's here for the second time, and that is Dr. Mohsen Saifi. Mohsen is the Vice President of Global Advanced Manufacturing Programs at ASTM International, and therefore has some really interesting insights to share with us today. Mohsen leads the initiatives that not only push additive manufacturing forwards, but really also connected to adjacent technologies like robotics, AI, even conventional manufacturing technologies. And therefore, today we'll also look a bit beyond additive manufacturing and into other advanced tech. We'll also talk about ASTM's broader vision and strategy from the Vols acquisition that you may have heard about also in one of our recent episodes, all the way to regional dynamics and how they are shaping additive manufacturing adoption. We'll even talk about some hurdles the industry is facing and also how certain regions and markets are accelerating. And last but not least, we'll also get a bit of a sneak peek into ICAM, which is happening in Vegas in the fall. So therefore, without any further ado, Mohsen, welcome back to Additive Snack.
Thanks for having me back, Fabian. It's a pleasure. I always enjoy these conversations because they give us really a chance to zoom out and look at the big picture. Obviously, additive manufacturing has been my focus for many years, but what excites me now is how it's intersecting and interacting with other critical and emerging technologies, as you said, AI, robotics, even some other ones like quantum, biotechnologies, whatnot. At ASTM now, through our Asset Center of Excellence, which is called Advancing Standards for Critical Emerging Technologies, an initiative that we established earlier this year, funded by NIST. We are right at that intersection. And that's really both a privilege and a responsibility because we know these technologies aren't just shaping manufacturing, they're shaping economies. They are shaping supply chains and even national security.
Yeah, and they're especially AI shaping the stock market today as well to very interesting and some would even say crazy levels. Before we go into all these awesome technologies, which I'm super excited to talk about because I think especially a podcast like this where we go so deep into additive manufacturing, it's really worthwhile to zoom out sometimes and look at the bigger picture. Before we go there, I think it's also interesting for those who are maybe not as familiar with ASTM. If you could maybe briefly talk about a bit of the history of ASTM and then the role that additive manufacturing plays within that organization. If I remember correctly, your first role at ASTM was also to kind of implement the technology of additive into that organization as the director of additive manufacturing. So if you could give us a bit of a background on that history and the role of additive within your organization.
Absolutely. Well, ASTM is one of those names a lot of people have heard, but maybe don't know deeply. We've been around since 1898. People sometimes imagine a dusty book of standards, but the reality is we're a global community of 35,000 plus members across 160 countries. Developing more than 12,500 plus standards across really many industries, around 90 industry sectors. When it comes to additive manufacturing, ASTM really became the enabler. Think of us as the infrastructure builders. Innovators may be driving the race cars, but we're the ones laying down the road, putting up the signs, and making sure everyone's moving safely and in sync. Without that infrastructure, you don't get trust. And without trust, you don't get adoption. So as you said, I joined the organization in 2016. We laid down really a strategy to build an initiative, a center of excellence, and a program that can really help drive the adoption. We've built what I can call an enablement engine. It has 3 gears. First is really pre-standardization, where we identify gaps, the needs of industry, map the landscape through our road mapping and workshopping and etc. Then it comes to the standardization, which is our core of the organization, where global experts come together, often in partnerships with other organizations. We write consensus-based standards. And then you have the standards out. These standards need to be implemented without having some sort of post-standardization activities. The adoption always would lack. So a standard on a paper means nothing if no one uses it. That's why we offer our training programs, really to educate the workforce, or certification programs where we reinforce the use of the standards, our advisory services to really build the confidence and the capacity in the industry. And what we have built and put this into action really bring basically the industry forward. The Additive Center of Excellence really was designed to bridge the research and industry together, and bringing the Bowlers Associates, which we can talk about it, into ASTM really gave us not just these standards, but also the market intelligence that will drive the industry forward. So now we don't just know how to do it, we know where the industry is going, and that's powerful.
Mm-hmm. Super interesting journey. And I think, over those past 9 years, you guys have really done a great job of bringing the industry together and creating those roads and road signs along the way. And I think in 2022 now, your position got elevated above additive manufacturing to look a bit broader at all advanced manufacturing technologies. Could you talk a little bit about the reasoning behind it, and also how you guys now view that larger portfolio of technologies within the manufacturing realm?
Yeah, when you zoom out, you realize really additive manufacturing doesn't stand alone anymore. It's converging with other technologies such as robotics, AI, advanced communications, cybersecurity, you name it. And here's the reality. AM is still less than 1% of global manufacturing. In 2024, the industry was about $22 billion. And that's healthy growth, 9% annually. But it's still a silver of the 12 trillion to 14 trillion global manufacturing base. For AM to break through, it really needs catalysts. AI is a very good, robust catalyst. You see it in generative design, for example, where AI helps engineers to create bone-like lattice structures or other lightweight structures that no human could design without additive. Or companies in aerospace blown brackets that are 45% or more lighter because of this.
Mm-hmm.
You see it in real-time monitoring. Companies can literally watch a melt pool and correct the defect as it happens. That's quality built in from the first layer. So it's really the conversion and intersection of a lot of technologies coming together in order to bring additive forward. In materials development, you see same thing. AI is being used to predict new alloy chemistries, slashing development cycles that used to take years down to months. Now, here's a catch. As an example, AI is only as good as the data you feed it. And right now, data is fragmented. Every machine OEM has its own format. Every company keeps its own files. And without massive, really standardized data lakes, AI will starve. That's why really ASTM created efforts like our Consortium for Materials Data and Standardization to bring really industry together to tackle the data problem. Because once you have the right data sets, once you have really the backbone, then AI can massively enable additive manufacturing to thrive. And now through our Asset Center of Excellence, which you can check out by visiting asset.com, we're expanding that thinking across AI, microelectronics, semiconductors, quantum, and biotech. We've really developed playbooks within our additive manufacturing sector that can be applied to other technology areas at different stages or TRL status. So additive as a fundamental technology, which many industries are leveraging, really created a foundation for us that now we're able to connect the dots and converging and bringing these trends together. It's, to me, no exaggeration to say that ultimately data is the lifeblood of intelligent manufacturing. Data is really the new oil. Without it, none of these technologies can scale. We're putting a lot of emphasis on that. Standards allow us to generate data. The data will feed back into standardization to continuously improve that. So it's really a continuous flow and relationship between standardization and data generation. Now, there are a ton of data out there that only few have access to. I think the question is, how do we democratize and bring that trust together across the industry, that we can bring all those data together to inform standardization, but also generate AI tools and things like that to make additive even stronger. So in a nutshell, I think, as you said, in 2022, we established the Advanced Manufacturing Division. We always had the vision to expand what we were developing within that division in additive, robotics, and other technologies, and bring it to other critical and emerging technologies. And now with the support from NIST and the government, we're actually doing it. So what we had as a vision several years ago, now it's becoming a reality, which is making it very exciting.
It's super interesting, and it does make sense to really look beyond additive and meet manufacturers where they are, which is they are challenged exactly with all of these questions. How do we now integrate additive manufacturing with certain automated post-processing technologies, for example? How do we leverage our monitoring tools to the fullest extent? And what the hell does AI mean for me and my operations? What is your feel on manufacturers out there? Is that are we in a stage where all of these technologies that are being advanced so quickly create almost like a daunting response from manufacturers, or is there a openness to explore and integrate AI and robotics alongside with additive manufacturing? What's your feel on that?
Yeah, there are a lot of conversations obviously happening around Industry 4.0 and even Industry 5.0. But in reality, we're still living in Industry 3.0 and in some cases, Industry 2.0. I think additive brings that digitalization really forward to the industry, but it's a journey. It takes time for traditional manufacturers to be able to really embrace these technologies and converge and integrate together. Some organizations, based on our viewpoint globally, have done that. And when we visit numerous companies, institutes, organizations, we started to see that convergence is happening. Convergence manufacturing is really a topic that we discuss quite a bit, and we think it really transformed the entire manufacturing industry. As you can imagine, manufacturing is quite enormous in size, but the true power of these adjacent technologies is still yet to be unleashed, in our opinion. So I think part of it is because of the overall pace, the trust, which standards bring that trust, by the way. We're working on it. We're working on developing really a robust set of standards driven by industry to help aid that convergence that needs to happen across the globe to take these technologies to the next stage. And I think additive is one of the key digital technologies which leverages sensors, leverages autonomy, leverages Internet of Things, and so many other adjacent technologies. It's a great example of how we're going to bring it all together. So the near future, we envision a situation where you're going to have advanced in smart manufacturing, leveraging AI. Companies are building what do we call it as a nerve centers where you can really autonomously keep iterating, keep building new parts, new components, and AI will be able to drive a lot of that, and a lot of innovation could happen. And that's what really excites us, because I think we're going to be in a very exciting journey in the next, I would say, 5 to 10 years, seeing that convergence happen.
Yeah, it's an interesting thoughts to really see what impact those technologies are going to have on manufacturing and localized manufacturing. And I want to save a few of those topics for a little bit later, because I definitely want to talk about, what does that mean for a lot of the global reshoring initiatives? What does that mean for topics such as ramping up defense spend in the NATO, especially in Europe? And I think, that all of those targets and goals might actually be somewhat challenging to achieve without additive, without AI, without those advanced technologies, because we don't have the experienced workforce anymore in a lot of those Western countries. But let's table that for a second, because I do want to get a few more topics out of the way first. The first thing is we had Mari and Scott on a month ago or so. They gave us a really great insight into the updated Volas report. They gave us really interesting insights into Volas Associates and what type of services you guys provide there. Can you take us a few years back to the point of acquisition of Volas? What was that strategic thinking behind it, and how that organization fits into the ASTM ecosystem?
Yeah, when ASTM brought the Fuller's Associates into the family, it got a lot of attention. In fact, I remember that press release we put out with respect to that acquisition. It became one of the top, well-received press releases by the organization globally.
Mhm.
And I understand why. For nearly, obviously, 30 years, Wallace Report was the Bible of the AM industry, and many refer to that report as a crown jewels of the industry. And for me personally, it was a full circle moment. I used to cite Wallace Report in presentations, in my talks, in a lot of articles, papers, whatnot. Now, I help shape it. So we have a team now behind that report that really takes it to the next level. The beauty of the acquisition was really around the synergy. ASTM builds the standards, Wallace provided the compass. Together, we've evolved the report, and in 2022, it was about building that synergy. And then in 2023, was about sustainability and bringing a stronger theme into that report. 2024, we tackled the myth and misconceptions holding adoption back. We talked about a lot of those in the report. In 2025, we zoomed out, really linking AM to the broader set of critical and emerging technologies, and really transformed that report quite substantially. Are we done yet? We're not. We think that the knowledge consumption market has evolved quite significantly because of AI. So we're continuously thinking, exploring, innovating around that report to bring the best-in-class knowledge and intelligence to the community so we could really bring the industry forward. So the team has evolved quite significantly. We have brought several key experts to that business. And the market intelligence is one side of the business, and the other side is the advisory services, where we provide a strategy, road mapping, guidance to the industry, leveraging that market intelligence that we capture on a yearly basis. So when we acquired Dollars, it was a couple of hundred companies that we were tracking, or it was being tracked by the Dollars team. But today, I can mention that it's in excess of 5,000 companies globally that we're tracking. The number of people who are contributing to that report has expanded substantially. The team working behind that report is much bigger and is stronger. We're bringing the ASTM neutrality capabilities and expertise to produce a report that really stands out. And I think confidently we can say that it's just still the go-to report of the industry. Many are referring to that report to devise their strategy, create roadmaps, define their investment strategy, and whatnot. And what excites me the most is actually the future transformation of that report, where we are really envisioning a lot more capabilities to be added to that report and the way our users and clients are going to consume that report, leveraging massive amount of data, the past 30 or so years of information that we have captured, bringing AI and capabilities into that report. So there's a lot of excitement within the team, and I'm glad that you were able to talk to Maddie and Scott about those. So Maddie is leading the market intelligence side, Scott is leading the advisory services side, and all coming together with the team. I think we're really providing the support that industry is needed to advance and take the industry to the next level. So,
Yeah. And what I thought was really cool as well is that you guys brought the report a bit more to the modern era, right? I think the format is awesome. And what I thought was really great is that give access to the background data for companies to dig a bit deeper into some of the aspects of the report. So I do think that is very helpful for the additive manufacturing industry.
Absolutely. And if I can add one more thing is, I think through partnerships with many organizations, been able to bring this report to a lot more people. An example, in the US, if you're an American Mix member, you get this report that has continued along. But we also built additional partnerships with many organizations globally to provide that. So today, I can confidently say that we're not just giving the industry the rules of the road with the standardization, we're also giving the map through our market intelligence. And that combination is quite powerful.
Staying with the theme of a map, ASTM historically has been a US organization, right? But I think interestingly, especially in the past years, you've also set up additive centers of excellence in various other countries and regions. And what I'm curious to hear from your insights there is, how do you see different regions adopting additive manufacturing? How do they differ in maturity from European countries to countries in the Asia Pacific region? Where do we see interesting trends and growing adoption? Where do you see a bit of a flat line? What is your overall feel on the global adoption of additive?
Yeah. So first of all, ASTM footprint has been really global, although we are based in the US, but we work with 160 countries globally. Our members are from international communities, and our customers are all around the globe. We do have offices in Asia, in Europe, in US, North America, South America. So we're truly an international organization, but this has been in a journey about, again, started about 30 years ago, I would say. The ASTM really internationalized and globalized its reach beyond US borders. And one of the privileges of my role is really seeing how the adoption looks around the world. And I had the privilege to travel to more than 20 countries over the past, I would say, 8 years, seeing what's happening in those regions, in different countries, different uh, economies, and really to assess how we can help the entire industry globally to move forward. Now, if you look at Europe, there's a large focus in aerospace and medical, deeply tied to sustainability policies.
Hmm.
Aerospace companies, there are leaders here, and regulators are closely involved in regulating the technology. We do have a fair amount of collaboration with European countries. In the UK, we do have a very strong team. We're involved in a massive government-funded program. I would say it's the largest UK-funded activity in additive manufacturing is something that we're involved heavily. We based our hub in your region in the UK, but we didn't stop it there. ASTM has an office in Brussels, and we continuously work through that with the policymakers and a lot of key organizations. But also beyond that, Germany has always been a region that we have been collaborating, especially through our DIN friends who are leading or secretary of the ISO TC261 committee. We have a team now in Germany, consists of about 3 individuals. Overall in Europe, we have about 10 individuals working with different countries, UK, Germany, France, you name it. So we believe that AM is really a global technology. You need to be aware of what's happening in those regions, but also connecting the dots and bringing capabilities and collaboration together. Obviously, in the U.S., defense and supply chain resiliency dominates. We could talk about that. The Navy Supplier Activation Program is a good example, building a qualified AM-ready base of suppliers. I think that's a topic worthy of discussion.
Hmm.
Looking in Asia Pacific, Southeast Asia, a lot of innovation is happening. If you look back 10, 15 years ago, I think the technology was less mature in those regions. But now today, we can confidently say that this story is a story of a scale. In China in particular, you walk into factories with farms of printers, hundreds of metal printers running in parallel. It's just staggering. But without, again, harmonized standards, all that innovation risks is staying in its own bubble. So I think it's quite key for us to bring that international perspective together. And
Hmm.
when we're working with those regions, we're really connecting the dots, realizing what's happening across the supply chain. What are the capabilities? How do we collaborate further across those regions? Bringing like a glue those countries and regions together. Some of them are U.S. allies, some of them are not. This is why really ASTM global presence matters. We're not exporting a one-size-fits-all model across all the regions. We're connecting the ecosystem, trying to reduce duplication of efforts, and making sure really innovation in one region can benefit everyone in other regions. So we do have a really robust global strategy, and we think that
Hmm.
continues to evolve and allow us to enable further industrialization of the technology.
Interesting. No, you obviously have a great footprint there, and therefore also great insights into global adoption. Are there any surprising hidden champions that you can think of? For example, right? I mean, we have the obvious big players like in the US. We have Germany, and also the UK. I would say in Europe. Obviously, China in Asia Pacific region. But there's also, I think, countries that have very rapidly adopted additive manufacturing in the past couple of years and really accelerated their adoption. Ukraine is a good example due to the Ukraine-Russia war that they have adopted additive significantly for drone production. Are there other countries like that where you can see that acceleration in additive adoption that's maybe not commonly known?
Interesting question. Through our Singapore office, we work with many Asian countries, Japan, Korean, uh, Philippines, Malaysia, whatnot. So I think for us, that continuous monitoring allows us to really understand where things are heading towards. I don't think I would say a surprise. It wasn't a big surprise for us, but I think China is really a standout when they are really investing heavily in additive manufacturing to a scale up. And China is being known for making the technologies cheaper, more affordable, and basically wider accessible. So I think the innovation, the development that is happening in China is going to significantly impact the global markets. Again, like I said, 10, 15 years ago, it wasn't the case, but I think now we see that China is moving quite rapidly towards scaling up this technology, reducing its cost. Often we see the cost of their machine one third, one half, or even more in some cases of the Western machines. So that competition exert a lot of pressure in typical companies out there and been innovating and inventing the technology for a very long time. So in the Middle East also, and I would say MENA region, we started to see further expansion and interest in digital manufacturing, additives, especially in some areas that they're very good at, like energy sector, construction. We started to see a lot more adoption in the Middle East, for example. Overall, I think through 12 time zones within our team, we're really trying to continuously monitor what's happening. And the greatest, I would say, is the Australia. Australia created what they call it Australia Makes, which is somehow very similar model as America Makes in the US. And they have recently received government funding to establish this center to create really a robust ecosystem. I think Australia was really lacking that. We're very glad that that happened. ASTM is part of that initiative. And the launch was going to happen in October, where we actually also try to conduct a training program at the same time. So we think that the connection and the expansion is happening in Asia through New Zealand, Australia, and then Southeast Asia, Middle East. And that connection to Europe and US, I think, will make this technology stronger. And we all need to realize that, again, nothing will happen in silos. This is a collaborative technology where no matter where you are, which country you are, I think there are capabilities that can help move everybody forward, and we're trying to make that happen.
Mm-hmm. No, I couldn't agree more. It's a collaborative technology across industries, across countries, across players in and outside of the space, right? Need a whole value chain to pull along. And speaking of that, as you mentioned, you guys monitor additive and its adjacent technologies continuously. And we have these highlight countries and industries that we'll touch on in a second, like certain defense sectors that are really adopting additive quite rapidly. But for the others that are still a bit left behind, what are some of those hurdles that you still see that we haven't talked about that is really inhibiting the adoption of additive?
Fabian, every disruptive technology goes through growing pains and cycles. And for AM, there's no exception. There are really large hurdles that are quite known, in fact, that we've been talking about these for the past 10, 15 years. Notably, qualification cycles are still too long. In some cases, 18 months or more to qualify a single aerospace part, for example. It's really taking us back. Supply chain readiness is another great example, which is a typical chicken and egg problem. Suppliers hesitate to invest without demand signals. OEMs and government hesitate to commit without suppliers' readiness. So that is quite a challenge, which in fact we could talk about it further. Costs are still relatively high when it comes to feedstock, often costs 10 times more than conventional materials. We need to look at the cost equation holistically, obviously, but still, if you look at each component of the AM value chain, the costs are high. Post-processing can take longer than printing itself. That's another key hurdle, which we talk about it quite often in the Woolers report. And anecdotally, there's a lot of discussion around what percentage after printing will be basically the cost of post-printing. It's often more than 50%, some cases 60, 70% of total cost could be the cost after printing. And then there's data issue, which we talked about it. Terabyte per generated per build in some cases. We captured the data with the hope that one day we're going to utilize it, but most of it goes unused because it isn't standardized, and we're essentially still behind in analyzing and basically using that data. But this is quite natural, we think. I call it our adolescence phase, right? The AM is kind of grown from its infancy and it's now getting into adulthood. The next maturity phase will be really defined by the predictability of additive manufacturing. One of our colleagues at Rolls-Royce said once, we'll know AM is ready when it's boring. Boring doesn't mean uninteresting, but it means predictable, repeatable, and trusted. I think that's when you know really technology has industrialized, and that's where standards come into play. Often we measure maturity of an industry sector by the number of standards around that sector. In AM, when we established the AM COE, we had less than 20 standards. Today, we have over 80 standards published within ISO and ASTM, plus other in that standard bodies who develop the standards. So we can see that the maturity is continuously going up, and I think that will allow us to overcome some of those hurdles. There are policy issues that exist. Those needs to be addressed. The risk taking is not high. We put a lot of scrutiny into additive compared to traditional manufacturing because of the risks that we can't take easily. And I think those are the things that needs to be addressed. The cultural inertia, that's always the case. And I think within organizations, within larger MNCs, within regulators, there's always inertia for the adoption. So having said all of those, there are still opportunities too. If you want to talk about it, we can look at the other side of the spectrum too.
Yeah, let's flip the coin. And to your point, the last time you were on this podcast, we made a deep dive on standards, and if I remember correctly, the number was roughly 60 standards. So now being at 90, I mean that's an incredible 50% or 80. Was it 80 or 90 or 80?
80, yeah, 80 plus.
Yeah, but 30% growth, right? I mean that's a really good trend just in a few years. So we're definitely trending in the right direction. Yeah, and you mentioned opportunities in that space. In the beginning, we also talked about AI, which I think can be a great opportunity to get over some of those hurdles, right? From data collection to qualification. Love to hear your thoughts on that. There's also the workforce itself, where maybe additive and AI together can attract the next generation back into manufacturing, which I think we haven't seen in a long time, right? It's kind of like a bit of a almost a unique thing to do for a young person to get into manufacturing. And I think that's maybe changing a little bit. So yeah, what are your thoughts on on opportunities to accelerate that adoption trend. Because if we just go linear, it's gonna take quite some time. To your point, we're at 20 billion versus the $14 trillion overall industry. That's a lot of linear growth to go through.
That's correct. So I think one of the beauties again of our position within the industry is that we get exposed to a lot of success stories that in some cases they are untold, and we're trying to bring those success stories into the market, into the industry's attention via various platforms that we have created. Obviously, World Report captures a lot of those stories and bring those into the basically line of sights for many, so they can understand this industry has came a long way. So the opportunities are really enormous. In aerospace and space, as an example, AIM is already flying. Boeing aircrafts within, for example, or GE engines, thousands of fuel nozzles in service. We know that there are thousands of parts that are flying on Boeing aircrafts or Airbus aircrafts or others. In the space industry, companies like Relativity Space printing 85% of a rocket by mass. These are enormous. And I think without AM, a lot of these applications couldn't be enabled. So in medical industries, more than 250 FDA cleared devices are now on the market. These were not the case a decade ago or 2 decades ago. From orthopedic implants to dental aligners worn by millions, 3D printing is really making a difference. In sustainability, AM really could be transformative. I think lightweighting AM parts can really cut aviation fuel burn by more than 15% in some cases. On a single trip from Singapore to New York, which is the longest one, I often take that route, close to 19 hours. You're generating 300 tons of CO2. We actually did a calculation. Multiply that across the fleets, and we're talking about 500,000 tons annually, easily. So AM, imagine by reducing the weight out of those aircrafts, by introducing AM into those aircrafts, I think we should be able to significantly impact the carbon footprint generation. In fact, one of our existing projects funded by America Makes is focused on sustainability, and we're trying to bring around clarity on what AM can do and creating a database of materials, whatnot, to measure carbon footprint and things like that. So, and there is AI-driven workflows, right? First time right builds, born qualified builds, predictive maintenance, which is a huge topic, accelerated materials discovery, developing new alloys, leveraging, again, AI enabled by AM. Those are all kind of exponential growth. They're not linear. If we can make it happen, I think we're going to be able to significantly bring AM to the next level. I'll share another story. A small Navy supplier once told me that before AM, they were invisible. Now they compete with primes because they have the technology capability that once the only primes had that. So that's really democratizing the power of this technology, which I think it creates new opportunities, new avenues, and make it really exciting. So those are some of the ones
awesome.
would say, yeah.
Yeah, it's a cool example. It kind of shows how additive is giving smaller players an opportunity to differentiate themselves in a market that is typically dominated by established large players, and therefore really gives you an opportunity to accelerate, and probably also gives you an opportunity to attract talent, attract capital, and really push ahead. Now, speaking of, I do think that the defense sector and the DoD has been a really great catalyst and accelerator of additive in the past. Especially in recent years, we see various programs launched, such as the Maritime Industrial Base focus on casting replacements. Speaking of additive boring parts, can't get more boring than casting replacements. But it's a really beautiful story of the supply chain benefits of additive. So, um, from your perspective, how is defense accelerating additive adoption, similar to the example you just mentioned with that small player? How are they creating opportunities? Where are still struggles of the DoD in adopting additive manufacturing? And what should we expect in that sector overall in additive?
Fabian, defense is actually really outpacing the overall AM industry's growth. We monitor different sectors quite often. I think space, aerospace, medical have been always kind of growing quite rapidly. But over the past several years, due to sequence of events and whatnot around the globe, I think defense is really outpacing the overall AM industry in terms of growth. Main reason is really resilience in national security. So we've gone really from printing test coupons to now qualified heat exchanger, for example, for F-35. We're printing spares at sea. The Navy Suppliers Activation Program, which you are aware of, is really building an AM-ready supply base right now. So there's a lot of activities and growth, but hurdles still remain. Qualification cycles are too long, and we know that. The workforces are still catching up, and the trust in data is still fragile. Now, when we zoom in on the maritime sector in particular, specifically, two priorities stand out: supply chain readiness and the workforce. These two are really are typical hurdles that we have across the board, but in maritime sector, it became really received a lot more attention. On the supply chain, the facts are really sobering. If you put all U.S. additive suppliers together today, they still couldn't meet the Navy's demand. So we need to scale. But before scaling, we need readiness. And that means auditing suppliers, understanding who meets requirements, and really creating pathways to upskill, reskill, and cross-skill those who don't. That's exactly what we're doing right now within a program in partnership with Blue Forge and Austal USA. We're harmonizing what has historically been a patchwork of qualification frameworks, because you don't even want different standards for 7 different DoD programs, right? You don't want to have duplicative standards for many of these programs. You want one trusted framework that is scalable. Here's the analogy we use often. Imagine you're building a submarine, right? You don't hand 7 different rule books to the shipyard workers and say, pick one, right? That will be chaos. Give everyone one trusted playbook and enable them. Standards really serve that purpose. They bring order, consistency, and trust, and that's what we're trying to do with this program. And then there's workforce. A submarine, imagine, has over 1 million parts, right? Many are unique, and they have long lead, and they are critical. To leverage AM, we don't just need machines. We need people. We need qualified personnel. That means welders and machinists learning AM, design tools to be able to work with AM. Inspectors who understand digital twins and in situ monitoring, for example. And embedding standards literacy into training so operators can really know how to navigate them. So we're very fortunate and privileged to work with EOS, obviously, in one of these programs to enable that workforce which is quite exciting. And this is what we call building an AM-ready workforce. And it's not just for Navy. I think the same skills apply in commercial shipbuilding, offshore energy, renewables, and you name it, right? So what we're building here, transferable to other technology sectors as well. So the bottom line is this: collaboration isn't optional here, right? It's survival. We have to collaborate here, and the supply chain is so fragmented that demand signals are urgent. The only way to scale is to align strategies, share intelligence, and build global partnerships. That's what we're doing, and it is how maritime ecosystem won't just catch up; it will lead, and it will enable other industry sectors as well.
Very interesting points. And yes, also from my side, very excited that we're working together on educating the future workforce for the maritime industrial base. If there's any listeners out there that want to get trained on additive, we'll put some links into the show notes where you can sign up for that training program. It is an interesting role model for other parts of the DoD, what the maritime industrial base is doing. And I also recently heard a U.S. general talk about how the Ukrainian Department of Defense has been able to compete with a Russian Navy without having a Navy, has been able to compete with a Russian Air Force without really having an Air Force. And I think one of the key elements here is additive manufacturing. It has allowed them to rapidly deploy new innovative concepts for warfare, from drones to unmanned submarine vehicles, etc., etc. And therefore, with the recent commitment of NATO to commit 5% of GDP to defense, and I think that kind of splits up of 3.5% to core defense and 1.5% to related resilience and innovation. I'm hopeful for additive that that playbook of the MIP, that playbook of the Ukraine, of really leveraging additive as an agile technology to innovate, but also leveraging it as a supply chain tool to get around the exodus of manufacturers in our respective countries. So what is your thoughts on that? Is additive viewed by NATO countries as one of the tools? Do we still have to do more education work there to put additive on the map, or what does that look like?
Yeah, big time, Fabian. I think if we zoom out, resilience is really the theme across many of those countries, evident by their amount of investment. So your plan to invest 5% of GDP into defense really underscores the urgency. Traditional factories take years to build. AM hubs can be stood up in months or days. That's resilience. The example that you mentioned really shows that too. The ability to stand up in theater 3D printing, for example, capabilities, or even behind the scene, enabling AM hubs to produce parts that are needed for warfare, things like that. So really make AM as a key component of building resiliencies. And I think we've seen not only in NATO countries, but also other parts of the world, the significant amount of investments going into defense, and large bit of that basically relies on advanced manufacturing. If you look at the U.S. Department of Defense budget, latest one, over $1 trillion investment, a big portion of that actually emphasized the advanced manufacturing and these technologies. UK similarly have decided to put a really significant amount of their GDPs into also additive manufacturing with respect to the growth. I think it's 2.5 to 3% that they are putting in. There's a growth phase for that in the next couple of years. So all of that shows that countries are looking at these technologies as a key enablers for resiliency. And geopolitics matter. I think countries that are basically trying to stay ahead of others are really understanding the strategic nature of additive manufacturing. And we have seen many organizations in different parts of the world taking the lead, bringing those defense allies together. For example, European Defense Agency is conducting several key workshops, activities to bring the countries together to emphasize about the importance of additive manufacturing. And then it goes back to that convergence that I mentioned, right? It's not just additive. It brings, you got to bring autonomy, you got to bring AI and other capabilities all combined together. Then you have the true readiness. That's why we think that activities like our Asset COE, which is, by the way, it's the U.S. Standardization Center of Excellence for Critical Emerging Technologies, really bringing all of these converging technologies together, I think will help that resiliency long term. And I think there's no question that countries will invest continuously into this.
Yeah, couldn't agree more. And one interesting aspect that just came to mind as well is, the more we build up defense capability with additive manufacturing for resilience, especially during peacetime, but really also maybe even especially during wartime, you'll start to see innovative approaches that will spill over into the private sector and into non-defense innovation, right? So you could definitely see all of the drone advancements spilling over into agriculture drones and so on and so forth. You could see the sub and surface autonomous vehicles spilling over into rescue missions and so on and so forth. So there's definitely an interesting secondary effect that we could see where additive will find its way into other sectors by leveraging defense innovation and defense output. Now, one of the conferences in the industry that is really helping to shape that innovative character of additive manufacturing, in my opinion, is ICAM, a conference that is hosted by ASTM. Like I mentioned at the beginning of the show, it's happening in Vegas, which is a nice side effect as well. So tell us a bit more about what people can expect from that conference this year.
Or to be an exciting ICAM because we're celebrating the 10th anniversary of this event. What started as basically a simple 1.5-day workshop turned into a full-blown conference with 26 symposia, bringing over 850 talks and drawing over 1,000 participants from 45 countries, really is just getting bigger and bigger. We're very proud of this conference because we believe truly that it's one of those top conferences in the field that it's bringing the technical authorities, industries, governments, research institutes, all kinds of organizations across the ecosystem under one roof to really talk about the implementation, talk about applications, and how companies are embracing additive manufacturing. Fabian, there are a lot of trade shows out there, right? And exhibits, which are great to see the latest and greatest technologies advancements. But when you go to those shows, often people really underscore the challenges and the pain points that is involved with additive. So at ICANN, we actually look at both sides. What are the opportunities? What are the excitements? But at the same time, what are the hurdles? How industries are overcoming those hurdles? How research is enabling applications and informing standards? What are the gaps? and creating really basically a dialogue across the entire ecosystem that can move the industry forward. What excites me is the cross pollination. A defense engineer and a medical researcher sharing a panel together, an AI scientist and a manufacturing lead brainstorming together. That's where things are sparks fly. Essentially, one of my favorite moments last year was a PhD student presenting on a digital twins. The aerospace executive in the room were buzzing afterwards, and that's what ICAM does, essentially. It reminds us that innovation is global, and it often comes from unexpected voices. And that student was from Singapore. The executive was from a U.S. company. He was very excited. And this year, ICAM will also be really good for us, a platform for asset or other CETs. We're taking the AM playbook and applying it to AI, other technologies, robotics. There are tracks for some of those adjacent technologies. And ICAM is where those lessons learned will be shared, how conversion is happening, how AI, robots, and additive are coming together. But it's going to be super exciting. And this year will be even bigger than last year, despite some of the other conferences that were struggling to maintain the growth. All the markers for ICAM performance points towards a stronger ICAM even this year compared to last year, which is quite exciting. And again, if you look at the audience of ICAM, it's quite different than many other conferences. The quality of the attendees, the speakers, and the countries, bringing that collaborative spirit into ICAM, I think makes it really a unique conference. So we're very excited.
Awesome. Yeah, same here. Excited about that event. Seems like it is a event that really summarizes ASTM well, with the international character, with the focus on research and collaboration. So yeah, I'm hopeful that a lot of innovative conversations come out of it. This to me, it was also a very awesome conversation, Mohsen. I really enjoyed going high and diving deep at the same time with you today into various aspects of additive manufacturing, but also into the broader picture of advanced manufacturing. So I'd like to thank you for being on the show today.
Absolutely. Again, thanks a lot for having me on the show again. And wrap up my final words is really ASTM role is to build the infrastructure of for trust, trade, and transformation for technologies moving faster than governance. Additive manufacturing gave us really the playbook. We created that playbook. We developed that foundation. The asset COE is now the expansion of those playbooks. And in all of that, data is really the lifeblood. We're working on some very exciting transformative efforts around data, which I hope that we were able to be able to share more of those opportunities in the future. The stakes are high, I think, but the foundation is really strong. And I'll end with this: whoever writes these standards, write the future.
Wow, great ending, man. I appreciate that. Couldn't agree more, especially on the data is the lifeblood, and therefore this is really just the beginning of another growth curve of additive, without the hype in this case. And for our listeners out there, thank you for joining us on this in this conversation with Mohsen. If you want to learn more about ASTM, check out their websites. If you want to learn more about ICAM and sign up, just Google ICAM. And if you want to learn about the training program we just discussed, you can just Google Navy Supplier Training by EOS, and we'll also add some links to the show notes here as well. If you like this episode, share it with a friend, colleague, or anyone you think should learn more about additive and the global as well as regional implications of it. And yeah, don't forget to subscribe. If you have comments or questions, post them either on LinkedIn by tagging Mohsen and I, or comment in the YouTube channel. This was the Additive Snack Podcast. I'm your host, Fabian Feld, and I will see you next time.